Welcome to the Climate Cafe Green Blue. We do it in English this time. It's something Flores and I are doing for years already. We're gathering knowledge about green blue infrastructures, bioswales, floating solar panels, infiltrating roads, and all different kind of stuff. I'm Sydney Staks from the municipality of Nijmegen, background in ecology and civil engineering for water. And today we have Omar, who's doing one of our Flores and ours favorite topic, the functioning of bioswales. So because of the time, we always try to keep it a little bit short. And then I think it's time that Omar can introduce himself. Do you have a presentation, by the way? Let's try share it, and then you can introduce yourself. So then I would say the floor is yours, as we say here.
So yeah, thank you, Sydney, and thank you very much for this kind invitation. My name is Omar Al Masalmah. I'm a PhD candidate by TU Delft and Water Management Department. I'm originally like a civil engineer. I have 2 master degrees in water engineering and in sustainable engineering design and construction. And before I joined TU Delft, I worked with the SWECO here in the Netherlands for around 2 years in asset management and using GIS application for asset management. And now I'm working with the Jeroen Langfield and Zoran Kaplan for asset management for blue-green infrastructure in the Netherlands. And today I will present part of this PhD project, and I hope it will be informative for people. Yeah. So I will start the presentation. Yeah. So good evening, everybody. This is the topic of the presentation, failure mechanisms in bioswales. So briefly, what is my PhD project? It consists of 4 parts. The first one is to conclude the failure mechanisms from the literature, from the inspection reports, from all the available documents. It was a kind of like theoretical study somehow. The second part is like to go to the field. So I went there with other like colleagues, 2 master students, Abdullah and Sayag. And we have inspected until now around 500 bioswales in the Netherlands. And today I will present the work of these 2 parts together. But we're supposed to produce in the third part a kind of inspection protocol with the aim like to provide a systemized inspection process to make it like more uniform, more objective. And this is include this example, 5 levels for quality with the clear definitions like about the failure, what is the definition, what are the different categories, how we can differentiate between them with the aim to minimize the subjectivity and to make the communication between the different stakeholders is easier. And the third part is like to quantify the same failure mechanisms so we can have like numerical based analysis with the aim to know like what is the probability of occurrence of these failures. So the first part is like to know what are these failures and then to quantify them with the aim to allocate our resources in very efficient way for maintenance, for planning of other activities. And the fourth part, is like to model one of these failure mechanisms to see like how the degradation, if we can predict the degradation and somehow, so we can do then a kind of a preventive maintenance. So this is like a summary of the PhD project, but I will explain today only the first 2 parts. So first of all, what is a bioswale? A bioswale is like shallow and vegetated channel is normally within an urban area. It has some visible components for the people who are walking aside, and some parts are invisible. It consists like of a filter strip. You have side slope, main channel, you have an outlet, and sometimes also an emergency overflow. And all of these is covered by vegetation. And underneath you have like a sand layer, gravel layer, and surrounded by a geotextile. And you have a barefoot infiltrated pipe, like to collect and drain the water, and all of this within the native soil. And you have, of course, the groundwater level that goes up and down. And the main inflow comes like from rainfall and side inflow. But these bioswales, they fail from time to time. And for example, for this like example that you can see on the screen, you have like illegal barking, you have stress vegetation, you have inappropriate trees location, you could have also invasive weeds on the plants, you have soil dumping on the side that block water inflow from the side. You could have like structural damage or even like misalignment of the outlet that could be like in the same level of the main channel. And this means like water has like no time to infiltrate through like the whole body of the soil. So what we did, like our methodology, like we have determined our scope, and then we did like BGI's inventory to identify like what are the components that we are studying. And this is very important because BGIs in general and bioswales also in particular, they have different designs, and it's like most of the time tailor-made according to the local needs, according to the list of benefits. So that's why we need to do first like an inventory for the components and what are the standard condition, performance, function, and services. Sometimes you have like acceptable like condition, but the performance is reduced, but still deliver the required functions and services. So we need also to distinguish between all of these terms. And then we try to define and determine like the failure types. And then we decided how we can detect them from literature, from field inspection, and experts' judgment. And then we are looking to analyze the data to decide what are the vulnerable components and why. So this is just an example of the like fault tree. Like you have here like top failure of the acid of the bioswale, and this failure could happen because of many reasons. One of them could be the flood, and the flood could happen because of many events. One of them, if you have excess water and the emergency overflow or the outlet is not functioning or not exist. And the excess water, you could have it maybe because you have now more water drainage or more like hydraulic overloading, or maybe because the infiltration rate is less than the water load. And this could happen because of many reasons. And then you go down and down and down until you like build like a big faulty tree. So in this case, I can show you like you have reduced infiltration rate because of compaction of the soil or maybe a clogging in the top layer. The compaction could happen because of construction of equipment that works from the bottom, or maybe because of the barking, like that car that was barking there could like clog the soil at that area, or maybe if you have a traffic there, could clog and compact the area. So many reasons. And if you took all of these like events, root causes and the intermediate events, and then until you reach like to the failure module. So you have like a big tree like this one. And this tree counts for 203 unique failure mechanisms. We have seen that clogging and hydraulic overloading are the key failure mechanisms, and vegetation is the most sensitive component because it's shortly time dependent, which means like you need to maintain it per season, and this is not the case for other like components like the inlet and the outlet, which made like from beton and cement that needs longer time. And most of these like failure mechanisms have been concluded by expert assessment in combination with literature review. And then we have analyzed the root causes or the basic events, and we have found that most of these events that initiate the failures, they come from the bioswale itself. They are internal, and most of them through the design and the operation phases. Some they came from the interface with the urban environment. For example, if you have a pavement between like the street and the bioswale, these numbers are like little, like 10 root causes, but they are very significant. So if you have like a pavement, then the water cannot go inside the swale and the swale is not working anymore. So they are less in number, but they are very significant and very important. And some other external factors, but mainly from internal. And then we have analyzed these basic events or root causes, and we have found that the most like critical root causes, they are frequent pedestrian traffic inside the swales, maybe people who they are walking their dogs because they are not aware about the system, or they want just like to make a short course, like moving from one side to another. Also, you have invasive weeds and the plants and wrong type of vegetation. So these are the most critical root causes that regularly and more frequent happen, and they lead to failure in the whole system. So what we did like an inspection for 507 bioswales. They were like in 5 Dutch municipalities in Amsterdam, Rotterdam, Utrecht, Nijmegen, and Eindhoven. And this was like during July and September. So I will present today like some results from Amsterdam field inspection because they are a kind of, I would say, representative for the whole, like the rest of the municipalities. And they are really quite diverse, like in terms of different type of failures. So they are very informative and very representative. We have inspected 53 assets between 21 and 25th of July during or after rain events. And this gives us the chance to investigate how do they operate during or after the rain shower to see if they are functioning or not. Most of these bioswales, they were within urban land, mainly having like residential, transportation, and commercial activities. Some of them, they were close to construction sites or industrial activities or industrial areas. They receive water from different sources, like from road, sidewalk, roof drain, car parking, feedspad, or cycle road, from bark, from drainage pipe, and mainly they drain water to sewer system and the groundwater, and rarely to surface water. Here you can see like the results of the condition assessment per component, and we have decided to make it per component, not per asset, because if you want to make it per asset, you need to make a relative weight for each component, and we cannot say like inlets are more important than the outlets or the vegetation or filter basin. I think this is something could be like kind of subjective, so we decided to keep it like per component and to make it as objective as much as possible. So you can see like the bar charts are quite like logic for inlets, for filter basin, for outlets, emergency overflow, and other components, and very predictable. But for vegetation, they are not. And the main reason, as I explained before, because of the short time dependent of the vegetation, they need regular and more frequent maintenance, and this does not happen every time. They are very costly. So I will show you some examples, like what do we mean by like wrong integration or misintegration. For example, here you have seen like you have a pavement and a gully butt between a street and bioswale. So water has no chance to go inside. The same is happening in this example. So another department, like after constructing a bioswale, like made a pavement, so water cannot go inside. Or maybe like you have here like a soil dump, so water from roof drain cannot go inside and they have backflow outside. Or from here also the feedspad is not connected with the bioswale. These are examples of like misintegration. Here below you can see that the gully butts is exactly in front of the inlet of the swale, like here and here and here and here, this one and this one. And even here you can see the gully butt, the inlet, and the outlet. So water quickly goes here. If it has a chance, maybe there is a clogging to get inside, then it goes quickly to the outlet, which is like wrong design, I would say. For the inlets, particularly, you have some examples like of physical damage, like here, or maybe you have like clogging and blockage examples, but here this is blocking by leaves, greenery. Here, like leaves of trees. In this example, they are accumulating inside, but in case of operating, you have clogging and water goes outside. In this case, you have a lot of vegetation and sediment lip also in front. Here you have physical objects that blocking water flow by people installed here for like decoration. And if you go closer, you see there is a depression also. Or even you have like higher pavement, a couple of centimeters. So water goes like to the gully butts in the neighborhood. Or even you have debris. For vegetation, you have like bare spots like this, or you have like a lot of leaves of trees. Of course, like these, for example, could like break down and they can like make small particles, and these small particles can clog the infiltration basin and reducing the infiltration rate, and then the water load becomes higher, and then you have excess water. And in case you have the emergency overflow or the outlet is not working, then you end up by flood. So this is how the process starts. And all of these are examples of the basic events or the root causes. Here you have like long vegetation. Here we have inappropriate or wrong vegetation type. So it's very big vegetation with the small roots, so you have uprooted because of wind. Here, after vegetation maintenance, they didn't remove the grass clipping, and they can also break down until they make small particles and clogging. Or even you have very short grass, or even different type of vegetation, which is good for biodiversity, but not good like for a bioswale if you want to have like a treatment for the water to optimize the quality. For the filter basin failures, an example could be like you have wrong profile, because you have like two channels, not one, and water like walk here and then goes like inside and then comes here. I think that it has been like another type of facilities, and then has been changed, but not like optimized or like rehabilitated to become a true like bioswale. Or maybe you have a clogging, full clogging, and you have bonding for a long time, and you can see like from the green color, and we have been there and we have seen some also mosquitoes. Or maybe you have like erosion, soil erosion or channelization, or even sedimentation. And this is just an example like of, we did like some soil sampling just to give an indication how is like the performance of the filter basin, like is it keeping like good permeability. So this is like a good example. If you have like for this profile you have sand soil and a little bit of organic matter, and then you have the grass. But in this example you see how much you have like of peat soil, and in this example you have very full like peat soil and even compacted, and we think water is not easy to go inside. For the outlets, you can see like some other examples, like mainly by people, like children toys, some trash also here, rubbish. I think here this is like an example of like not ideal selection of different components. For example, like you have installed an outlet in this type close to a road made from this small loose material, and then this loose material goes inside the outlet, and it has here like a depth of 30 centimeters. It's almost close like to the pipeline. So you need really like to take a lot of this material outside to maintain it. And maybe it's not good like to combine both of them together in the same location. Or maybe like a physical damage like this one. This is opened. There was here a locker, and this is also removed. Or maybe here like you have partial clogging or buried. And also for other components, we have seen many other components. This is a good example like for the flow spreader. So on behalf of you have like one like point source, you want to make it as a sheet flow on behalf of channel flow to not to prevent the channelization. But as you can see, because of the accumulation of the debris and vegetation, it's not working anymore like in that way. So water will like concentrate here and go there, and it's not easy. This is a good example for Of course, we had many good examples, but this one is very important, and I wanted to highlight it here. This is like an inspection and maintenance path, which is very good because it allows you to not make a damage to the vegetation, and it guides you easily to the inlets and outlets. Because sometimes it's really hard like to find where are the inlets and where are the outlets, especially if you don't have like accurate data, which is the case for all the municipalities almost. They lack of really like good quality of data, and you need to look like behind, and sometimes you have very dense and long vegetation. Some examples of people behavior also, people like normally claim they use also like containers, but when you go like close, you can see they put like sand on the ground or like some other trash. The same is here, you can see it. Or maybe they add like some other components like for decorative or spiritual reasons, or maybe here some plants and then it's broken and then the vegetation goes there and the soil goes inside, or even like barking partially or completely, or using like heavy vehicles maybe for maintenance or even like by other people, like here for other department, other construction. Sometimes you have flood planning. For example, in this case, you have like here a private garden, and this is the bioswale, but you see there is a kind of connection between them, and the sediments moves between the private garden to the swale. So maybe it's good like to install here like small pavement to make this connection between both of them. In this case, like another department have split rain garden to two sections to install electrical box, but they are not that much connected like before. Or even you install like a trash bin in the corner, so you see like the vegetation has been reduced around, and this becomes also a source for pollution, like with the wind, or maybe people not exactly like put the trash inside, so it goes inside the bioswale. So for the field inspection, we have used this inspection form. It has like 11 pages, but I show you like the main like sections. So we have collected administrative information, like the code of that swale, who is the owner, the address, the managers, it has been inspected before or not, is it accessible or not, something like that. And then we collected information about the swale itself, like what is the type, the length, the width, from where you receive water to where you drain water, if there is like any citizen complaints. Then we also included information from previous maintenance activities. Normally, you don't have this in the database. Not every database has this information, but also from the field, you can feel it. Like if you see the grass is already mowed and trimmed, or even the trees, if they are already trimmed, if it is clean or not. So we also make some notes. And then we collected some information from the surrounding environment, like from the weather, if it is rainy or not, when it was the last rain. Also about the land use, land cover in the area, if it is like residential, is it like agricultural, is it like industry, what is happening there, the soil type, the water, groundwater level. And then we did like the condition assessment. It was a qualitative, like excellent, good, sufficient, poor, or something like that, for the different components, like for the type, for the material, for the design alignment, for the this is a result of misalignment, what happened. Yeah, if there is like a blockage, if there is a clogging, if there is a contamination, structural damage. And we found there is a need like to create an app to make this inspection, because we couldn't find like a good application for bioswales. We have seen some forms, but they are like very short, like around 2-3 pages to collect very selective parameters. But this is not the case that we are looking for. We want to collect a lot of information, not only for the research, but also to prove that other type of failures could exist, and we need to document like some information that exists like with the inspectors, not only like in the guidelines. Also, the inspectors who they are in the field, who they are dealing with this real world, they have also their inputs, and they are very important. So we had to look also for our like form. And then we came to the available apps like a QField or maybe digital forms, but they have some limitations. For example, like these lists, they are very complex, and QField is not able like to deal with them. Sometimes you need like very flexible like form, which means like one swale could have one inlet, one outlet, but other swale could have like 3, 4 inlets and 3, 4, 5 outlets. So you need to create sublists according to your need, and each one could have like 15 like a question. So you need like really like to just create by one click a lot of questions or like delete them rather than go scroll down all the way like in the other forms. And Google Forms, for example, has a limitation of 200 questions. And also we had the difficulty that the database itself that we get from municipalities, they are a kind of poor because they provide us with polygons for the swales, but there is no inventory information like how many inlets, where they are exactly, so we can go there quickly and inspect them. So besides to the inspection, we have to do inventory, and the inventory is before the inspection. And that's why we have created our app. Of course, we want also to organize our data within specific tables according to our needs and some other like advantages to make automatic reporting to the clients. So we have created Inky Track app, this one. Yeah, we call it Inky after the Sumerian god Inky for water and wisdom, creation and magic. And the track because we are doing observation. So we decided to get some inspiration from Mesopotamia. I belong to that area, so I decided to add something like from that area also in the process. This is an example like how the automatic reporting could be. So after you finish the form and you click submit, you get like a report like this, a PDF form. It has the title, the ID of that asset that you do it, that you did the inspection. It has been inspected by whom, when, and some administrative information. And then you have like these like tables like that has like the information with the photos that you made. Also, you can browse it like on the website. You open like the website, the app, and you see all of your assets. And if you click on one of them, then you have an online report, and then you can make an edit if you agree or disagree on this as like an asset owner. So the main conclusion, visual inspection of Bioswale is very informative, but must be uniform and objective. All components are vulnerable to failure, and most of root cases originate from the bioswale itself, especially from the internal design and during the operation of the bioswale within the environment. And maybe recommendations for the future work that I'm going to do. And I hope also to see like other research in the same like direction to quantify the failure mechanisms, because also it's not only enough to know that you have like all of these type of failures, but also you need to know like what is the probability of occurrence, so you can like allocate your resources and plan efficiently for your maintenance activities, and also to try to produce a standardized and effective inspection and monitoring protocol, so everybody can goes like after or before or anytime he can collect the same kind of information, and we can easily like understand each other. So we have clear thresholds for failure, for quality, and this will avoid like the uncertainty and the misunderstanding. Thank you.
Thank you, Omar, for this great presentation. Really clear, really nicely presented. So we don't really have audience because Floris and I are the moderators, but that means we have more time for questions for our own, which we are very happy about, I think, Floris, because it's one of our favorite subjects. Who will start, Floris? You go ahead. I already talked some, so you start, Floris.
Great topic, great
Your connection is worsening, Floris. I think you have to put it in the chat because we can't hear you right now. Luckily,
It's
we have.
not working. Oh.
No, it's not working. Sometimes it's working.
Okay.
Maybe you should put
Yeah,
it in the
maybe you can
chat
try now. Yeah.
or try it again once more.
Yeah, exactly. There's one point, maybe important point, to make it uniform. It's not working, or
It's
Yeah,
working.
okay. Oh, okay, great. Yeah, one point before we cut off. I really like the procedure, but it will be depending on the municipality. For example, Amsterdam, those are not failures. They intended to have the sidewalk a bit higher because they want to have the first flush to the sewer system. So the first millimeters are intended to be there. So we have to be very careful what we call a failure or not. So we cannot do it uniform because that will be different than Sydney will see it, for example, in Nijmegen. That's my most important point. And maybe you take over Sydney before it cut off, but that's an important point to make, I think. Yeah.
It was working, but yeah, exactly. That's an important thing. However, I think this list and this whole broad overview of failure is still very useful. Actually, I've been a manager for Bioswales green infrastructure for about 4 or 5 years, and I was always missing a list about things. And every day when we had a failure, it was something else. Almost every day. After a few years, of course, things start repeating. And in some cases, it wasn't really a failure. Like for the example, like that Flora said, but also I come across, I like that you talk about it because it was one failure I was thinking about a lot, and that is leaves in the bioswale. We have some bioswales full of leaves, and they work perfectly. This is again depending on how much water goes in there. These are bioswales that are not have a heavy load of water. They are quite shallow, and there are not a lot of other factors that are problematic. Still, I always recommend, well, if you can remove leaves, let's do this. But there are municipalities, and for instance, also we, that say to some failures, it's not a problem, or at least it's not a big problem. So what I still like is that we have this whole list of failures between brackets, and then still the manager itself could always say, well, I don't think that's really a failure in my case. And I think that could also be really important for your research. I'm hearing a little feedback from myself, by the way. That's annoying. But that's a thing you should pay attention to. Like Flora said, is a failure always a failure? And in some cases, there are so many factors that one failure mechanism doesn't really mean that you have to take action right away.
Yeah, true. Maybe if I can comment on that, because like what Flores mentioned, actually I have received the same comment like from Amsterdam, because I said, yeah, really they want like the water to goes like to the sewer, and in case like the sewer like is unable like to manage all of that, then the bioswale is working like as a buffer for that system. And I really agree like on this. But also we need like to define like what is the meaning of failure. And when I tried to work like on this project, it was like for me kind of like of floating like work, because I don't know like from where to start, because there is no consensus like at least on the national level. And the way of like municipalities, they like manage their assets, like every municipality can create their own like regulations according to their local needs, which is good, because like it's really like fit their needs. But in case like if you lag behind like for the regulations, for the terms, then like we have like a kind of a problem. So what we have decided like to talk about like the ideal situation, and that's why we try also to make a differentiation between what is the meaning like of a condition, performance, function, and service. So sometimes as Sydney mentioned, like you have maybe like a problem, like a lot of leaves like into your like biosphere, but still like the performance is good. And sometimes even like the performance could be like reduced, but not to a degree
Yeah,
that force you to start like a maintenance, because
exactly.
you will invest a lot of time and money and effort. And the function is still working, and there is like no problem with the end users. So it's still like delivering the designed services. So that's true. So I agree, like in general, but this is like how we decided like
Yeah,
to design the work. Yeah.
I think it's a great approach because I think that's another step. And I already think it's so much work what you're doing. You're doing something that I thought of sometimes doing, like, oh, try to map all these failures, and I just gave up because it's so much work, and I don't do a PhD on this topic, but fortunately you do. But still, even only the mapping, and after that you can start linking it a bit more to these performances. But I have like a question or suggestion. What I really like is that you're making these quality levels.
Yeah, this one.
And of course, those are, especially this example, I think it's even, it looks a bit like the CROE, the standards that we have in the Netherlands. Yeah, I thought so, that you do. I really love it, because they do say something about performance a little bit. Especially these can say something about performance. This is a great example where you can see, yeah, of course, the performance is reduced. And in practice, you could see, like, for example, that at C or D, it starts functioning below the performance level that you want, and maybe above B, it's fine. That would be great. But then you have to link it to the performance.
Yeah, yeah, that's true.
Yeah,
And that's why like we try like during like the condition assessment, like to collect like some indicators for the performance. Sometimes like
yeah,
it's not possible like to assess like the performance, but at least we get some indicators. And also we understand like the decision could be like different between like the inspector and between like the asset manager. So that's
yeah,
why we try at least to establish such like for this 5 levels like of quality. And this is like truly like came after like the CRO beeldkwaliteit catalog for openbaar ruimte. Like it's the same methodology, but and they have also some tables that could fit like the Bioswales, but not enough. We need like to expand this a lot, and maybe it will be like a good contribution from our side. But also, as I told you, like it depends like on the literature, on the experience that we have, and we need a kind of like contribution from all the stakeholders.
yeah,
At least we can then establish something, and then we can optimize it a little bit here and there. But we need to start maybe. Yeah.
yeah, yeah. No, I really like it. I really liked it. This overview that you start making. This something that I would love to have when I started working here on bioswale maintenance. So it will be really useful anyway. And I have some question also about what you came across in the field. Did you maybe find like different failures between cities that are like typical? You don't have to mention the cities per se, but I was just wondering, that would be interesting as well, of course.
Yeah, actually, we have seen some, and I think it's okay because, like in Nijmegen, for example, most of the new bioswales they are like in a specific neighborhood, which is like in newly established. So they already like built these like bioswales, but also they still doing construction activities. And many
Yeah,
of sediments they came like inside the bioswales. So this is like one, I would say, like very common like type of failures there. And there is like some special cases, and that's why we need to make it like numerical. And I think also still this like fault tree, the qualitative and the numerical one, will be dependent on the country. For example, like if you go to Canada, maybe there they have like a lot of snow, and they like apply a lot of salts like to melt the snow, and then maybe these like they go like inside the swale, and then you have like dead vegetation, or maybe you need to have plants that they are salt tolerant. If not, then you have a failure. If yes, then maybe the salts also could accumulate within the filter basin. So maybe they have like their own like unique failure mechanisms. But I think we have like the general one, and maybe you can add something or remove something. Or maybe if you add, if you calculate the probability of occurrence, something could be like more probable here in the Netherlands is less probable in Canada or the opposite. So we try to make it comprehensive as much as we can, but still there is a room for optimization always.
This is nice. This is nice. The numerical part that you're doing is nice because we the costs that we make of bioswales is just like, and we have of course an overview per year of what we come across, but you can actually make an yeah, even a calculation about what can occur in the next years. That's really nice. That's also often lacking this kind of insights. All right.
Yeah.
Yeah,
Maybe I
Floris,
can
yeah,
try.
I wanted to give
Can
you
try to. So because it's quite extensive, the amount of bioswales.
you're we don't hear you again.
Oh, I was
Yeah, now
trying to
you're back.
ask.
Now you're back.
Yeah,
Oh.
that was good. Yeah.
What is the percentage of swales that you would find a failure, or up till now? Is that a high percentage? Could you say something about that?
No, it's not that much. I mean, like for
Okay.
example, like let's say like normally municipalities they are focusing on the flood issue if you have a flood or not. So like for the bonding in the filter basin, we have seen only 2 cases out of 53,
Okay.
which means it's like
Yeah,
44%. But still, like other like bioswales, they have different degrees of failure in different like components, but they still functional. They're still operating.
Yeah, great. Yeah, I think that's an important message because
Yeah.
if you see the presentation with all the lovely pictures with failures, you
Yeah.
might get the impression like, what are we doing with the green
No,
infrastructure? Yeah, so that's a very good point. And maybe before my connection cut off, I sent a lot of notes in the chat that might be helpful. So mostly the check by stakeholders because every municipality is different. Actually, different person in the municipality might give you a different answer about failures, for example. So that might be someone. Sydney and me.
Yeah.
Oh, there have been some ClimateCafe online where apps are already available about accessing bioswales. That might help. We can send you the presentation. In this case, it was Tau that did it, but there are more consultancy agents that do that. And also, there are 3,500 bioswales on ClimateScan. It might be nice to review them as well. Actually, you can do that with AI. Assess them, for example, and also 300 of them are having the tag of bad management practices. So that means that something is wrong, mostly by Antal Suman that you already were in contact with. So that might help to get the numbers higher, to get more, because it's already extensive what you do, but get more numbers will make.
Yeah, you're cut off again, but I agree. More data.
Yeah,
help.
exactly.
You're back. Yeah, you're back.
Oh,
And actually,
yeah,
also
just
we are.
yeah.
Please.
Oh no, just saying. Most of my notes are in the chat, and we can have a chat after it, if it's if my connection is better when I'm back from India. Yeah.
Yeah, actually,
So,
I also like try to optimize like the inspection process itself. So that's why maybe I need like these inputs at least like for the permeable pavements and retention bonds. But for sure, I will try to include them for bioswales also before like we publish like our paper because it's now almost ready, and we want to make it also like available for the academic community to receive like some feedback on that work. Yeah.
so you always do. You're also doing this for retention ponds and other green infrastructure.
Yeah, but this is
nice.
the first part.
I thought it was only bioswales.
No,
Right.
this is the first part of bioswales, but still I have the other 2 parts. Yeah.
All right. Oh, that's great. Yeah. And another thing I was thinking about, and it's he's not really joining us, but he is recording, is that he's working with AI. Maybe I'm not sure yet, but we're trying to get a research starting with AI that's spotting at least where is a bioswale, bioswale, but also trying to solve the problem like where are the inlets and the outlets. And I was thinking I don't think this is in the research yet, but with AI. For example, with satellite data that comes around the planet for about like 5 days, it's actually too short to really measure if it's a failure or not. However, I think in the future those data can also be used, and then you can link that again to your amazing data set of failures. That has so much potential. It's really great. Yeah.
Yeah, actually,
Yeah.
it's good to mention that I just like came from a workshop in Azures, and there was a colleague there who is working on using a drone to detect like the failures or like for assessment of
Ah,
bioswales. And he told me like he used like only like 60 images like to train the model, and it was like able to detect like the failures in vegetation.
with
So
only
I see this
60?
only 60. Yeah,
Whoa. Okay, that's a great
yeah.
model.
I think like he said like the results are promising, and we have presented like some of them. So I would like to discuss this also with my supervisors if we can include this part in our PhD project, in my PhD project. And then if we can really like do this like by AI, then we can easily like do the inventory part and also the condition assessment part.
Yeah. Great. Right. I'm really looking forward to read more about this. On what phase of your PhD are you?
Yeah, I'm still like in the second,
Okay.
but the first and second, they are the biggest part because you need to do an extensive literature review and also to do like the field inspection itself. So I think now I would say like I'm in the middle, 50%. Yeah.
Okay, so on
Nice.
schedule. Yeah. All right.
Yeah. No, maybe.
Oh, you're breaking off again. I will say
Oh,
what.
yeah.
You're back.
Yeah,
Yeah, you're
I'm
back.
back.
All right. Okay. So because it's very important, some municipalities have more than 5 swales, right? And it's getting higher up. I mean, probably in 10 years, every municipality has more than 300 bioswales. So this is very labor intensive. So we should use AI or indeed drones or other mechanisms to justify if we need maintenance or not. So very important research. Yeah.
Yeah,
Thanks.
yeah,
I was also wondering, well, just thinking, of course, from my point of view, actually from my former job, and also a lot of information we gather through, how do you say in English, meldingen,
registration, complaints of the system.
complaints. Yeah,
Yeah,
complaints. Yeah, that's complaints is a
yeah,
bit more negative, but yeah. And actually, what I noticed that they do get documented, but often after a few time, all these pictures take a lot of data, so they are not always saved for many years. But it actually, if you have like this app, it could also be used for those kind of
yeah.
complaints. Yeah, so not
Yeah,
even only inspections, but general data through the year. Yeah.
yeah, actually, like we had some ideas about that. Some of them we have included like in the inspection form itself. Like there is like in every component apart, if there is like comments or like complaints or reports or information from the local citizens, like because they see us like in the field and they become curious and we see them also there. So we have some discussion. If you have seen like a flood or a problem, if you understand how it works, the system, and many of them they are cooperative but they don't know how it works.
Yeah.
And we have seen some good examples, like some municipalities they install like boards to explain the system for the locals. And maybe it would be a good idea like if we can like include there like a QR code connected like with a small like inspection like form, maybe 3 4 5 questions like with some figures like this one for the main or the most like probable failure types, so they can also like do it by themselves and they can contribute like to the data collection. But I think yeah, what you said is good, and some municipalities they already have like good database for the citizens' complaints, but is not related to the bioswales itself. It's like more general, and it's a kind of like qualitative, like description and talking, and we needed like to be like more accurate to minimize, facilitate
So
the analysis, I would say.
so you can use the data.
Yeah.
Of course. But it sounds really cool. Then you have like a board, and that would say, does your bioswale still works fine? And then you can check the QR code.
Exactly. Yeah.
That's a really great idea. I have never thought of it doing it like that. That's nice to also to get people just getting involved. Yeah.
Yeah.
Great. All right. Yeah, I'm just really looking forward to read about it sometime. So I hope we see you back when you're further in this research. Flores, do you still have important questions?
No, I think before I cut off, most of the things are in the chat that might help you. Existing apps, climate online episodes that we can send you. Very good to verify. Of course, every municipality is different and every design is different. There are guidelines. It's not a law. So from that perspective, there's no failures. And it needs measurements, of course, to really see if it's a failure or not. And the best measurement is a great stormwater event and seeing what actually works or not. And there's a lot of gray infrastructure that doesn't work as well. Could be considered as a failure, I would say. So that's about trash. That's about idiot-proof with parking. Great examples. Of course, we don't want that, but it doesn't mean the bioswale is not working correctly. And also removing the vegetation doesn't have to be a problem. Actually, it's intended by some municipalities because of CO2. You keep it in the bioswale. So basically, you improve the environment and also the soil type. It doesn't actually matter if it's sand or peat. A lot of municipalities use existing soil. That they don't need the filter layer to be 2 sand and 3, humus-rich water. It's a guideline. So also that's not a failure. But so that's basically what I wrote down. And because of my connection is bad, I just said it. And please visit ClimateScan. There's a lot of bioswales and already assessment also there that you could use. And I think together we have a extensive knowledge. There's no country in the world probably now. So I think this is great work. Yeah, and can give a good name to green infrastructure. Because I'm glad that you didn't end with 90% is a failure. Just a couple of percentage. Otherwise, we're not doing the right thing. So great work, I would say. And indeed, let's have you back when you have more data. Thanks. Yeah.
Yeah. I think that's a great ending. Thank you very much, and we'd love to see it again. So,
And thank you also for having me and for the informative feedback. Of course, I will include it, and maybe see you next time.
Yeah, it would be great. So next Climate Cafe, Flores, you're already starting?
This is going to be about you.
Oh, you have to start over again because you were breaking off, and
going to be research about the RUG, so the University of Groningen, and it's about youth and climate. A topic we already brushed on in a previous episode, but it's nice to see updates. And it's very important, of course, to raise awareness and capacity building. Our new
last part broke off again.
That's the topic of next week.
Youth and climate. Youth and climate. Yeah, it came across clear besides the last part, but we hope to see you next time, people. Thank you, Omar.
Thank you very much. Have a good day.
Thanks. Bye.